Okay, welcome to the notes for lesson 3.5. This lesson is about markup and markdown problems. You may be not so familiar with markup, but markdown you should be quite familiar with. You see the signs in the stores and stuff. So we'll go over what exactly each one is. You have some formulas you can record down there. I made them nice and big so you can see them while I'm talking here. And then we'll go through several examples. I'll even give you some pointers on how to organize your results and your calculations and label things to make it much easier to follow along. So we're going to first go through the essential question: how are the concepts of percent markup and percent markdown related to the percent equation or percent proportion? I know a lot of you seem to prefer the percent proportion. Either way is fine, but percent markup is a percent of some cost, and percent markdown is a percent of some cost, but they're not exactly of the same thing, and so I want to make sure we're clear on that. So I defined these, and I got a little bit wordy here, so you don't need to write down each and every word here, but percent markup, you may not be super familiar with this because really stores do this. There's a lot of people that run their own businesses now, so they may deal with markup more than what they used to perhaps. But markup, any store, every store buys items. They don't, like Pringles doesn't make all of the items that they sell. They buy them, and then they do what's called markup. They simply mark up or raise the price that they pay to determine what they sell it for. So after a store purchases an item, they typically mark up. That just means raise, add on, the price a certain percent of their cost. So the store pays for the item and then raises that cost to determine what they put on the sticker price to sell it for. They do this to make a profit. If they sold it for exactly what they bought it for, they wouldn't make any money. So they have to make profit, plus they have to pay for their expenses and all that business. So that's a regular part of business. A store buys an item, they mark it up, they add that markup onto their cost, and that's what they put on the sticker price. And so that's what you as the customer see. You wouldn't see the price that they pay, and you probably wouldn't want to, because the amounts of markup are pretty crazy, I think. And then the one that you're much more familiar with probably is percent markdown. All these are sales. A lot of sales, they give you a certain percent off, like it's a 20% off sale or a 50% off sale. There are some stores that have all time, they have permanent signs that say they have a 75% off sale, and to me that's really sketchy. Why would they be selling it for such a huge discount all the time unless they ridiculously raise the price to begin with? So there you go. You're probably very familiar with this, the idea of a markdown. All that is a sale or a discount. The key thing is these are going to be percent, so we're going to use our percent equation or our percent proportion, but it's what you do with the results that is different. So some percent of the store's cost is the markup, and then that markup is added to the store's cost to determine the selling price. So to get the markup, you can use either this percent equation. That's great. Or you can use this percent proportion. That's great. I don't care which way you do it. But when you get a markup, that markup is added to the store's cost to get the selling price. You don't see the cost that the store paid typically, and you don't see the markup. All you see is the selling price. But all this happens like behind the scenes. So if we are told the store's cost and this percent, we can simply multiply them to get the markup, and then we can add that markup onto the store's cost to figure out what they're selling it for. If we are told the selling price and the store's cost, we can calculate the markup by saying, okay, how much did they add on? And then once we know that, we can use this percent equation or percent proportion to determine like what percent markup they used. And those would be two different kinds of problems that we do. So let's talk about the markdown a little bit here. So markdown, you're more familiar with this because this is what the end consumer sees. You see a regular price on an item and then you see it being on sale for a certain percent off. That's all stuff that you see. You don't see the store's cost and the markup because all that happened before the item came out for you to see. So how markdowns work, some percent of the regular price is that markdown. So that markdown is subtracted from the regular price. And a lot of times they'll show that right on the sales receipt and they'll be bragging to you how much money you saved. It seems like JCPenney really does that. We go Christmas shopping there and they always are bragging about how much money you saved by spending a bunch of money. But it's the same idea in terms of the formula. It's the regular price of the item, the price that you would see on the sticker, some percent of that is the markdown, and then that markdown is subtracted from the regular price to get the sale price. You can use the proportion if you prefer. Markdown over regular price is percent over 100. Or you can use the equation version. I really like the equation version, but I'll do some of these with the proportion because you all seem to like it better. I wanted to go through a few items before we get into the examples that can kind of complicate things. Another issue that can complicate things is when you go to the register, you have to pay tax. And that tax is also a percent of the selling price or sale price if it's on sale. So what that means is just for one item, one situation for one item, a store buys it for their cost. They mark it up a certain percent to determine what they put on the sticker. Then they can offer you a percent off sale, and that percent is figured on that regular selling price. But then they mark it down that much when they get to the register and they show you how much money you're saving. But then when you go to actually pay, they add the tax on. They calculate the tax. So in one situation, you have the price being marked up a certain percent because that's what stores do. And then you have the price marked down because it was on sale. And then you have tax being calculated and added because the government needs their money. So all that for one thing. So it could be kind of a complicated sort of thing, but it's very repetitive. All of them are percent of a number, percent of a number, percent of a number. Every single one of them is a percent of a number. So I really would encourage you to give the equation version a go because I really think it'll be the fastest route. You won't have to do all the cross multiply and divide stuff. Since they can be multi-step problems, it's important that you can make sense of your work. So make sure you understand what's going on first in the situation. Don't just start plugging and chugging with your calculator. Understand the situation first. Show all your calculations. Label it. If you calculate markup, write the word markup next to it. If you calculate tax, write the word tax next to that. And then make sure you've answered the question. For example, if it asks how much tax was added on, you don't need to find the total. If they ask for the total and you stop at tax, then you haven't answered the question that's been asked. So we are going to do some examples here. Not very many, really. 4, 6, 8, something like that. They'll be fairly repetitive, but I'll show all my work. I'll label things. And be sure to, if you're watching the video on your own, pause the video if you need to maybe see if you could work out the problems on your own before I do them. So let's go on to our first set of examples here. So here we go. This first one is about a cell phone case. So let's make sure we understand the situation first. So here we go. Marty buys plain cell phone cases and then decorates them to resell online at a higher price. What is the percent markup on each phone case? So we can see from this diagram, he buys it for $7.20, just a blank iPhone, or yeah, it looks like an iPhone case, who knows, cell phone case here. He gussies it all up with some graphics and he sells it, and we can see how much he adds on to the price. He bought it for $7.20 and he's selling it for $11.25. So he marked it up a certain amount, and we can calculate that. So markup is just the amount of the increase, and we can see what he paid and we can see what he's selling it for, so we can calculate that markup. And then once I know what that markup is, it is a percent of his cost, not the end result. It's the percent of his cost. So the first thing I'm going to do is I'm going to find the markup. And so to find the markup, I'm going to take the $11.25, his selling price, and I'm going to subtract $7.20 because that's what he paid for it. And so if we do that, we get $4.05. And what I was saying about labeling, I really think you should label this. So this isn't what he paid. This is what he is adding on to his cost to determine what he sells it for. So this is the markup. So he adds $4.05. That is the markup. But the question is, what is the percent markup? Really, this is just asking what percent of his cost is this? So we could use either the equation or the proportion. I'll use the proportion. You all seem to like that. So I'm going to put percent over 100, and then it's markup over the store's cost. And Marty is the store here. So the markup, we know, we just calculated it. So that's $4.05. His cost was $7.20. We don't know the percent markup. That's in fact the question. So I'm going to put a P for that and then put it over 100. And now we have our standard cross multiply and divide. It should be somewhat repetitive. So I'm going to cross multiply here. 720p is equal, and the other cross product is 4.05 times 100. That's a times sign. And then I'm going to divide by 7.20. Now, when I'm doing these myself, I probably would not use a proportion. I'm doing it this way because you all seem to prefer that method, and I don't have a problem with it. It's just a little bit longer for me. So I'm going to do that arithmetic. 4.05 times 100, and then I'm going to divide by the 7.20. And I get 56.25, but remember that's a percent, so I need to put a percent label on it. And I'm going to put M/U, that's kind of the standard abbreviation for markup. So he is putting on 56.25% markup, and that's to pay for himself doing some work. He's doing a bunch of work. Doesn't want to do that work for free, so he's adding 56.25% markup onto his cost to determine the selling price. So there you go. There's example one. So let's do one that is very, very similar, just with different numbers. So this one, instead of a phone case, we're dealing with an actual phone. So what is the percent markup on a $300 phone sold for $465? So the store bought the phone, they mark it up and sell it for $465. And we're asked, what is the percent markup? Well, we're going to do it the same way we did before. I'm going to find the markup by subtracting. And then I'm going to use either this proportion or the equation. I'll probably do a proportion each time since you all seem to prefer that method. It's all the same to me, really. So I'm going to subtract. And again, when I'm subtracting, I'm finding out how much did the store mark it up? How much markup was there? Well, that's pretty easy to do that subtraction, but I'm going to label that so I'll know what it is. There is $165 of markup. They added $165 onto their cost to determine what they sold it for. So now I'm going to write this proportion here. I'm going to put the markup over the store's cost. Well, the markup I just calculated, the store's cost, they paid $300 for the phone. And then I don't know the percent. I'll call it P. And over 100. So now cross multiply and divide. So here we go. 300P is equal to 165 times 100. And then divide by 300. One issue a lot of y'all were having is moving the decimal. So I guess using a proportion avoids that altogether. So maybe it's not so bad that I'm spending a little extra time doing a proportion. I'll never have to move a decimal doing it this way. So I took 165 times 100 divided by 300, and I got 55. And the meaning of that is there's 55% markup. So if you think about it, that phone company is marking up their phones a lower markup percentage than Marty is. But if you think about it, he's putting more time and effort into what he's doing, so it makes sense that he would charge more markup. They're just getting a shipment from the company and selling it. They're not doing a whole lot with that. So there is a couple of examples where we are finding the percent markup. Now we're going to do a couple examples where we find the selling price. So we are going to be told what the store bought it for, and we're going to be told the percent markup, and we're going to calculate what they would sell it for. So let's take a look at those. So here we go. Example 2, find the selling price. So here we go. The local furniture store pays $110 for a chest of drawers and sells it with a 40% markup. What is the selling price of the chest of drawers? 40% of what they bought it for is the markup that will get added on to that $110. So the first thing I need to do is actually calculate the markup. And I'm going to use the percent equation this time. The markup is simply this percent as a decimal times their cost. That's it. It is 40% of $110. And that is 0.40 times 110. And so 0.40 times 110, and I get 44. And labeling is super important. We need to understand what this $44 is. This $44 is not what they're going to sell it for. They will lose money. They paid $110. This $44 is the markup. It is how much they are going to add on to the price. So all we have to do is actually add that price on. So I'm going to do that. I'm going to take their cost plus how much they mark it up. And I get $154. And so I'm going to label that selling price. So that's what they would put on the sticker to sell that, or tag or whatever, on that chest of drawers. They would put a $154 price on it. If you think about it, they could offer a sale on this, and we're going to be getting into markdowns here in a bit, but they could offer a sale on this that would lower this price, but as long as it stays higher than 110, they can still make money on it. And that's how stores operate. They mark it up, and then they can mark it down a bit and still make money on it. So they're offering you a great sale, but they're still making money. So don't feel bad for the stores. So here we go. Let's do another one, finding the selling price. This one is very similar, just different sort of numbers. This time a store buys a pair of shoes for $45 and sells it with a 15% markup. What is the selling price? Well, it's going to be higher than $45 because they marked it up. So let's figure it out. Let's find out how much markup there is. So I'm going to find the markup. The markup is 15% of what the store bought it for is 45. I need to find 15% of 45. Using the percent equation, all that is 0.15 times 45. So 0.15 times 45, and I get 6.75. And I'm going to label that not only with a dollar sign, $6.75, but I'm going to label it markup. That is not what they're selling it for. That's what they're adding on to determine what they sell it for. So we need to take their cost and add on the markup. And I lined up my decimals there. So they are going to be selling it for $51.75, and I'm going to label that selling price. So there we go. So I calculated the markup, and then that markup gets added on to the store's cost to determine the selling price. So make sure you show your calculations and label things and put space between them and stuff so you can follow along. If you have your work organized nice and neat like that, I can glance at it and determine errors so much more quickly than if you just kind of scatter stuff around or show incomplete work. So let's do a couple more examples here, and then we'll be done. The last two examples are like sales. Something being marked down, all that means it's on sale. So when you have a sale, a lot of time it is a % off. Not always, but most of the time it's a % off. So in this first example for Markdown, example 3, we're going to find Markdown, but then we have an add-on issue of they add on tax once we get up to the register. So it's not a big deal as long as we break things down. Don't try to do it all in one shot. Do the sale and then do the tax. Do them as separate calculations. So markdown is a decrease. So I'm going to find how much markdown there is, and then I am going to lower the regular price by that amount. And that will determine the sale price. Once I know the sale price, then we can find a certain % of that is going to get added on for tax. So I'm going to find that and then actually add that tax on. So the first thing I'm going to do is calculate with this sale, this snowboard that is normally $180, it's on sale for 30% off. Well, I'm going to find out what is 30% of 180. So I'm going to find the markdown. So I'm going to write that down. I need to find out what is 30% of the 180 regular price. Well, that is 0.30 times 180. And then it's just a calculator problem. 0.30 times 180. And I get 54. And labeling is important. We need to understand what this 54 is. It's dollars, but it's not the sale price. It is the markdown. It's how much the store is going to lower the price. So I'm going to label that markdown, and then I'm going to do what the store would do. I am going to take away $54 from the $180 regular price. So to get the sale price, I'm going to take $180 minus the $54 sale. So 180 minus 54, and I get $126. So they are going to be selling that snowboard on sale for $126. Well, since it's on sale for that, they're selling it for that, the tax that's charged is figured of this lower amount. You don't have to pay tax on the full price because you didn't pay that price. You pay tax on this lowered price, which is a good thing for you. You don't have to pay as much. So now we need to figure out how much tax they're going to add on. Well, it says the sales tax in his state is 7.5%. So 7.5% of this sale price, so of the $126, is going to be the tax. Well, this is just the same sort of calculation as this. Yes, it's tax, but the idea is the same. I'm going to take this as the decimal, 0.075, and multiply that by $126. And when I do that, 0.075 times 126, and I get 9.45. And labeling again is important. This is not what they're going to sell it for. This is not what he pays. This is just the tax part of it. He's got to pay for this snowboard that's on sale for 126 bucks. Plus, he's got to add on $9.45, and that's what goes to the government. So we're going to take $126 plus $9.45. So a $126 item plus $9.45 of tax, and I get 5, 4, 15, carry the 1, 3, and I'm going to put total. So the regular price was $180. We calculated 30%. 30% of that 180 is how much off of the price it is. So we calculated 30% of 180 and got 54. And then we actually took that off because it said it was 30% off of the price. So if we take the $54 away, $126 item, but you still have to pay tax on that. So then we went up here and calculated the tax is a percent of this sale price. And I did that calculation and got $9.45 tax. And then I added that tax on to what he got for the sale price. And so he's going to pay $135.45 total. So there we go. Let's do one more. This one doesn't have tax in it. So this one should go a bit more quickly. It says find the percent markdown. So we have an $80 jacket, but it's on sale for $48. So the regular price is $80, but it's on sale. The sale price is $48. So to get the percent markdown, the first thing I have to do is figure out how much did they mark it down? How much did they lower the price of the item? So if I need to know how much they lowered the price, I need to subtract. So I'm going to take $80 minus $48, and I get $32. And that is the markdown. But the question is wanting to know the percent markdown. Well, the percent markdown is this $80 was lowered a certain percent, and that affected it by $32. So I'm needing to know what percent is 32 of the 80 regular price. So I'll do this one with a proportion since you all seem to like that. I'll write down the general formula. It's markdown over regular price equals percent markdown over 100. So the markdown we calculated was 32. The regular price is the 80. And then I don't know the percent, and it's always over 100. So now we have cross multiply and divide. So 80 times the percent equals 32 times 100. And then I'll divide by 80. And then 32 times 100 divided by 80. And I got 40. But remember, this is a percent, so it's 40%. And what kind of a percent is? Well, it's a percent markdown. So I'm going to label this markdown. So what all that means is there were probably signs by that jacket that said 40% off. That's all that is, a 40% sale. Not a big deal there at all. So if it's markup, that's getting added on to a store's cost to determine selling price. If it's marked down, that is being subtracted from the regular price to get the sale price. And then if there's tax involved, tax gets added on at the very end after any sales have been done. Then the tax is calculated, and the tax is always some percent of the sale price. So hopefully these examples will guide you on your homework. And the homework problems, I've assigned these 6. You're welcome to do more if you'd like. But the homework for 3-5 is 4, 5, 6, 9, 10, and 11. Make sure you show your work. Make sure you ask questions if you're not understanding. And make sure you label all of your answers, all of your work, so you can make sense of it as well as I can. So that is lesson 3-5.